All right, 17D. This is when the question starts talking about confidence intervals. In a nutshell, what they're trying to say is so far, there's usually a population proportion that we don't know. So for example, a statistic that I would say like 70% of students hate studying, right? But if I say that, where do I get that from? And the only way to do that is if I surveyed the entire students in the world and then I collected the data of how many people do like study. That's unfeasible, right? It's not feasible. So what we try to do instead, there is this P proportion that we don't know. But what we can do is we can get a sample proportion. So I can get a sample of students and then ask the same question. The question is, when I get a sample of students, so let's say this group here, I've got about 21 students in this class. Can I get a show of hands who like to study? Hands right up. We've got 1, 2. All right, we've got 2 out of 21. Okay, 2 out of 21. Now, that 2 out of 21, here's the question. How confident can I be that 2 out of 21 as a percentage, let's work it out. What's 2 out of 21? 2 out of 21. It's about 9%. Let's just say 9%, 10% for a good measure, right? How confident can I be that 10% of students in the state will like studying? Okay? Now, how confident can I be that this is true? That's what this study is about. So 17D is about you finding how confident can I be? Now here's a very relatable example that you can relate to what a confidence interval is and the logic behind it. Let's say you do your study scores, average is 30, you get a 50, and let's say they try to make the minimum 10, right? If I told you this, if I went up to Joe, I said, Joe, I reckon you're going to get a 40 plus or minus 50. And then I say, I'm 100% confident that that's going to happen. Do you believe me?
Yeah.
You do? Right. Now that makes a lot of sense. Why? Because when I said 40, it didn't matter at that point. This is my prediction. But the next part is this. This plus or minus 50% is what creates the interval. That's what you're doing in a confidence interval. You have this P, and then it's between two certain values. Now, Joe just mentioned just now, what are your intervals if it was plus or minus 50?
Negative 10 and 90.
And 90. Now, why am I 100% confident? It's because I know minimum was 10 and maximum is 50. I'm way beyond that. I've covered every aspect. What's the problem? Does this tell you much? No. So the more confident I am, the bigger my possible error. But one of the ways that we can reduce that is by doing more samples. Because the first scenario was, what if you only use one sample? How confident can you be that that is the actual population proportion? That's hard. That's what this study is about. It's the relationship between how many of these samples do I need and how bad is my error. Because the error, the smaller the error, the better. But the smaller the error means more likely I'm going to be wrong. So my confidence drops. So if I were to say to Joe now, if I said plus or minus 1, see, can I confidently say the same thing now? See, I won't have that same, it has to drop. But the reason why it drops is because my error reduces. Does that make sense so far? So that's the nutshell. Cool? All right, let's do. So now's the how and the do. So let's fill a couple of things because I haven't filled out the spots here. Can you fill out this one? This one should be 30. Just put a 30 there. And what I want you to memorize, don't start here. I'm going to make a video from this point. Don't cross it off, but I'll make a video from this onwards. Okay? What else is there that you need to know? No. All right, we can skip all this point. Language-wise, if you happen to look at your textbook and you're trying to learn instead of watching my videos here, point estimate is using sample to predict the population. So it's point because you're using only one to estimate. Yeah, so that's why it's called a point estimate. That's if you wanted to know that. Okay, so that's what point estimate actually means. It's just meaning you're trying to use the sample proportion to predict for the population proportion, which is really hard to find. Okay? Flip over the page, thank you. Let's flip over. All of this I will show you in a video to prove. This is what I want you to get to, and we're going to fill out. Here we go, this bit. This is the key part on the how. You just got to memorize that bit. Just got to understand how to use this bit, okay? All right, here we go. Here we go. All these arrows, we're going to fill it in.
Should there be a P to the right hand, P plus K?
Oh, thank you. Clearly, I was testing you guys. Yes, that is a P plus. All right. Let's fill out a couple obvious things. This here, this P is the true population proportion. This is the real data if we were able to get it, which we can't. This is the true population proportion. So that's like your population parameter. That's the name for it. Write it down, boys. Thanks. Next bit. What is this bit? So that's my current proportion. So this is the data that you have. Current proportion. So sample proportion. Actually, it's over here already. Sample proportion. What is this bit here on both sides? The name for that is called your margin of error. So the plus 50, minus 50 that I gave to Joe before. Okay, so this is your margin of error. Usually written as capital M, capital E. Okay, so this is what determines my error. And like I showed you before, the larger the error, the more confident I'm going to be. Okay, especially if the sample size is small. So the larger the error, the more confident I'll be. The smaller the error, okay, means I have to be more accurate, then the less confident I will become. Yes?
So is K what is K?
Very good. What is K? This arrow here, K, is the Z value for the confident percentage you're interested in. Okay, and I'll show you. So remember normal distribution chapter 16. So I'm going to draw a picture underneath this. And that's really the only bit I'm going to practice. I'm going to get you to do just to be able to find Z. Here we go. Do you know when we did this 68, 95, what was the last one? 99.7, right? So mean is here. To be 68% confident, you have to be what standard deviation again? 1. So 1 to the left, 1 to the right. This is 68%, right? Now, this is your confidence percentage. Yeah, so mean plus minus, that's your margin of error, yeah? Standard deviation. So, when you say 68%, I'm trying to ask for what is this area here? Well, actually, I'll make it 95 just to make it easier. So minus 2 plus 2. If it's 95% confidence, two standard deviations to the left and 2 standard deviations to the right. What's the area in these two regions? 2.5 each, because if 95 is here, there's 5% left over and symmetrical, so each one has to be 2.5, right? You need, yeah. Or, this is not approximation, it's not the true value actually. Yeah. So, 2.5, 2.5. Now this goes back to what Joe said before, but he was wrong for that scenario. This scenario, if I want to find Z, the actual true Z, this is an approximation. To find the actual Z value for this one, what do you use now? Inverse norm, because you know this is 2.5%. You know the standard normal, mean is 0, standard deviation 1. So you can find Z value. Let's do it. Here we go. Inverse norm, calculus, probability, menu 5, inverse norm. I want 0.025, that's the 2.5%. From left to right. And we get not 2. See, notice it's not 2. It's actually an approximated value of negative 1.95. Now that rounds off to 2 decimal places as negative 1.96. Okay, but because it's symmetrical, if this is negative 1.96, then this one has to be positive 1.96. Now, there is a formula to quickly calculate this. You can type in your calculator inverse norm, copy this down. Depending on how confident you want to be, you can do 1 minus C divided by 2. That's pretty much how I got. So 1 minus 0.95 divided by 2, that's how I got 0.025. Yeah? Mean is 0. Standard deviation 1. Let's practice your skills now. Can you find K for me if I want to be 70% confident? Find K. So in the formula, because you have to be able to find K. You need to be able to find K first. So find the Z value if I want to be 70% confident. So the center is 70. And each side would then be 15, 15, right? But you can use that formula. So you can do 1 minus 0.7 divided by 2. Work out Z for me. What does that give you? Do it. 1.04, let's see. All right, so I'm going to do it again. I'm going to type in the formula so you can see how I use it. 1 minus 0.7, that's the confidence I want to be, so 70% confident. Divided by 2, here we go. Negative 0.103 or 0.104, right? That's my K value. Let's try another one. What if I want to be 30% confident? If I want to be 30% confident, what would my K be? So K here would be negative 1.04 roughly. What's this one? Let's see. So I'm going to type it in. Here we go, 0.3. So 30% confident. Negative 0.385, which we can round off to negative 0.34 or 39. Okay, so now we know how to find K. All right, so we know how to find K and how it relates to the normal graph. Great. Next bit. This here, this entire thing is called your margin of error. And then this bit, what is this one called? What's this formula called? I know it says standard error there, but just in human language, what is that? Standard deviation. Yes, it's good. That's the formula I gave to you before. It's the standard deviation of sample proportion. So here, that's your standard deviation. But they also call it the standard error. All right, now let's practice. I want you to learn how to do it on a CAS, and I want you to know how to do it by hand as well. Now, last year's group, apparently, Bagier's group was really good at the CAS, but then on the exam, there was ones where you had to do by hand, and there was a difference between the Year 12 classes. There's a Year 12 class that practiced doing by hand, so they did really well in that question. I want to make sure my class can do both. Okay, so you've got a CAS, and you've got to do it by hand as well. So let's go to the next question. Here we go. Let's have a look at this question here. I've got a column for CAS. I've got a column for hand. Let's do this. Read the question. To investigate the TV watching habits of Australians, so it's a big population, a random sample of 50. Okay, I've got a sample of 50. People selected. It is found that 30 of them watch more than 2 hours. So I'll just write 30, right? 30 of them. So my sample proportion, how many people watch more than 2 hours of TV per day? Sample proportion, 30 out of 50. That's 0.6. So far, so good. All right. Now the question's asking, find an approximate 95% confidence interval. What they're trying to say is, I want, whatever the mean is, I want to be 95% confident that my proportion, I need an interval that this is going to be true. Okay, so this 0.6, the 6%, is it true? How confident can I be? What intervals can I be confident 95% of the time, right? So, for the proportion of Australians who watch more than 2 hours of TV. Now, here's the CAS version. You're going to go to menu. Oh, what's going on? What's going on? My computer's... All right. Here we go. Menu 665, which means I'm going to go here, menu 6, which is statistics. Whoops. 6 again, confidence intervals, which makes sense. That's what we're trying to do. And then now, what is 1 prop Z? 1 prop Z means you're trying to predict for one population proportion. Okay? That's what you're looking for, using this sample proportion, and you're trying to predict over the one population proportion. That's what this is. So I click this in. All right. Number of successes. Oh, wait. I'm just going to charge my computer. It's about to die. Woo. Type it in. So we've got successes is 30 in my population, my sample proportion. Woo. Here we go. 30.
What are we looking for? Like what's the looking for confidence? Lower? See lower? What's the answer?
The answer. Okay. Oh, did you press enter already?
Yes.
All right, good. I'm going to interpret that with you. All right. Can I get a show of hands who got this step? Show of hands if you got this.
Okay.
Okay, good. Oh, mine's in exact values. Let me do that again. All right, there. Much better. All right. What is this? Let's read it. This bit here on my CAS, did I screenshot it? I did. All right. This here is your lower bound. Oh my God, my pen's not working. This is your lower bound. Okay, so your confidence interval is between 0.464 to 0.735. Okay, this is how confident you are on that 0.6. So that proportion that you were saying, 30 out of 50 is 0.6. How confident, if you want to be 95% confident, then it will lie between 0.46 and 0.73. Okay, but that doesn't really tell us much. Listening? This doesn't tell us much because when I spoke with Joe before, wasn't it better that I said 40 plus or minus 50? You didn't need to know the negative 10 to 90. What you needed to know was the plus or minus. True? Because the error tells you more. So here, oh, finally it's working. Okay, ME, that's your margin of error. So if you take your p hat 0.6, take away this number, you get that. You can take 0.6 plus this number, you get this. Does that make sense? So I'll write it again. So if you wrote 0.6, take away ME, you will get this one. And if you did 0.6 plus ME, you will get that. So this is the margin of error. That's the error there. Okay, N is pretty straightforward. P hat, which we understood. But this is the CAS way. So a lot of students, you're more likely, when you're answering these questions, you're just going to type that in. Menu 665. Okay, and that will tell you all the information. But I want you to be able to do that by hand. So you should be able to get ME as this value, and you should be able to calculate on your CAS to get 0.464 and 0.735. So far, so good? All right, let's do it.
So, Mr. Chair,
Yeah.
this means that for a sample of 50 if you take a sample of 50 out of a large population, you are 95% sure that the true value of the proportion of people who like television is between 0.46 and 0.73.
That's it. But the 0.46 and 0.73
Don't
doesn't
mean much. It's the margin of error because it's 0.6 plus or minus 0.13%.
That's right. But most of the questions will actually ask how many people. So they'll have to give you a group, and then you take that percentage of the number of people. Then you can say 200 people to 800 people. I'm 95% confident they're going to watch more than 2 hours. That's true. Usually,
like probability level.
yeah. So it'll be. I would usually just do less than or equal. So greater than the equals. I do include, but it probably doesn't matter since it's interval. That's right. Yeah. All right, team. Let's do this. So one of the parts, I'll do this in a video where I describe what happens when you change n, and you should see the relationship. So the video will go into more theory. Today I'm just trying to go the how. Okay. So the theory will be for you to understand what happens when you change n. And how does it affect the margin of error? And how does the margin of error affect the confidence interval? The better you understand that concept, that's what makes 17D tricky. But if you don't want to understand that, then the knowing how is what this video is about. Okay? All right, let's go to the how now. This is my summary of it. If you didn't want to try it out yourself, that's the summary just below. All right, let's try to do it by hand now. Jump to the hand method. All right, team, let's do this. We want to be 95% confident. Now, you already you know how to find K. Okay, that was inverse norm. 1 minus 0.95 divided by 2, 0, 1. That's how you get the negative, the 1.96. I want you to calculate now ME. So this section here, this is ME. So if you were to do this by hand, if they gave you numbers that you can actually type in, then you can do that bit by hand, but you can use a calculator at this point. Okay, so work out ME. Is it true that ME ends up being 0.13579? So ME, square root, sample proportion, which you work out is 0.6, times by essentially 0.4, divided by, what's my N? What's N? 50. Let's see. Did I write 50? Yes, I did. Let's see what we get. So square root, fraction, 0.6 times 0.4 divided by 50. All right, I've got 0.069. What am I missing? Why doesn't this equal to the ME? What am I missing? Times by K, because this is only standard deviation. I haven't times by K yet, so times by 1.96. That was my K value. That's how they got it. Okay, so don't forget to multiply by K there. So you've just done this bit. Don't forget. That was, sorry, I should have fixed that. That's standard deviation. And then times by K becomes ME. Yep. Yeah, it would be. But in fact, this is not too bad because that's 6 over 10 and then times 4 over 10 divided by 50. It's still possible to do. They usually will give you K. Yeah, they usually will give you K. Or they tell you K can be or K is. Yeah. So in this case, it would be square root. Oh, actually, you guys all got that. What was that? 0.13579. All right, so far so good. And then to find your confidence interval. So now your confidence interval, you've got ME. So it's PR, the confidence interval of you being 95% confident, is between 1 P hat, which is 0.6, plus whatever you got for ME, and then 0.6 minus whatever you got for ME. You should then be able to get the answer on the interval. So you should be able to get your C1 and C2. So usually they ask you to find C1, C2, which is a confidence interval. So if I did on my CAS, here we go, 0.6 minus this answer, I get 0.464, which is correct. That's 0.464 there. So you can see there I've got lower boundary, 0.464. Try the other way, 0.6 plus, and you get 0.735. Does that make sense so far? Because that's one part of 17D. Part of 17D is to be able to do that process by hand. Okay, usually they'll give you better numbers. But that's how you do it. Cool? Let's see what time. All right, I still have about 15 minutes before I give you a bit of a break. Break is in, I can stop talking. It's more like me a break. I get a break. Okay, flip on to the last page. Oh, second last page. Second last page. All right. All right, team. Shh. Eyes and ears towards the board. Just a few more. Here we go. This page, we literally just did, so you don't have to actually read through this bit. This is me practicing with you before to find K. So this allows you to find the K value. I was teaching you how to find K just now. The formula itself tells you margin of error. Now there's one more formula. You can actually derive this yourself, but it's worthwhile writing down. Put this in your bound reference. Put like a star around it. Margin of error, which you can read from the confidence interval, they'll give it to you, but this one they won't give to you. This is essentially just rearranging the formula. So if you rearrange this formula to find n, so divide by k times by n and then divide it across, you then get that formula there. Okay? What's this formula for? This is when they tell you how much of an error they want. So with my case with Joe before, ideally, we don't want 40 plus or minus 50 for his raw score, right? What he would have preferred is if I gave him 40 plus or minus 1. And a better if I told him I was 99% confident that he will get a 40 plus or minus 1. See, that would be the ideal, right?
In exam, which method do you use? Which exam do you do the integral or do you do x plus or minus?
Sorry, I got confused there. Let me pull. All right, eyes and ears towards the board. Thanks, team. This formula is to work out the number, how large your sample size is. Now, on a logical sense, the more people you can test in a sample, the more accurate it's going to be. But if it's going to be accurate, then your margin of error will decrease. Okay, because less error, more accuracy. So this one allows you to find how big your sample size should be if you want it to be a certain accuracy. So in my case, if I wanted to make sure my margin of error is 1, I know how much I want it to be. Then I need to figure out, well, how big would my sample size be to make sure that I can predict with 99% confidence for Joe. Okay, so that will tell me how many trials I would need. Rather than just one SAC or one test, how many tests would I need to be that confident? Okay, so let's do one problem and then we'll call it, which problem is it? I think it is the one, yeah, it is this one. All right, let's do this one, team. So now you got a bit of the skills here, you got your CAS, let's do this. A sample of 5,000 Australians is selected and 3,760 have a brother. Now, what does that mean? What does that tell you already? What's the 3,760? Sample proportion. So sample proportion is 3,760 over 5,000. That's approximately, what is that? 3,760 over 5,000. 0.752. Rango.
Would it be statistically significant if there are two brothers in the sample?
I have no idea at the moment. I'm gonna do this one first, okay? All right. First question. Find an approximate 95% confidence interval for P. So P is the true population proportion to 3 decimal places. And, notice the key word, and I bolded and underlined it for you, number of Australians with brothers in the sample. I want you to use the CAS now. Let's go. Find a 95% confidence interval for me. What's the confidence interval? C1. Find C2. Let's go. Find C1, C2 for me. Menu. Go to menu. 6. 5. X success. 3,760. Oops, sorry. Sample size 5,000. I want 95% confident. This gives me the chart. Oh, sorry. I should change that to decimals. There we go. Much better. What does this tell me? C1 is 0.740. It said round to 3 decimal places. So C1 is 0.740 to, what's the other one? 0.763. 64, thank you, because there was a 9 at the end of it. Now that doesn't tell people much besides the proportion. So when we answer the question, C1, C2 we've got, that was the first bit, confidence interval. Next one is the number of Australians. That's more informative to people, right? So how do you find the interval? If I know the proportion is about 74% of them, and this is about 76.4% of them. So how many people? What's the interval range for the number of people? How do you work that out? That's it. Yeah. So you've got 5,000 people. I know 74% of them will have a brother and 76.4% of them will have a brother. That's how confident I am. 95% of the time. Let's work it out. If I times this by 5,000, because that's the proportion. If I times it by 5,000, what do I get? Let's work it out. 0.740 times 5,000. I get 3,700. All the way to 0.764 times 5,000, I get 3,820. Can you see how the language now makes more sense than if I said find an approximate 95% confidence interval, I would say I'm 95% confident that out of those 5,000 people, 3,700 to 3,820 of them will have a brother. See, that makes more sense than me saying 74% of them to 76.4% of them. It still works, but it's harder to understand. Does that make sense?
Yeah. So the 95% means that if I did 20 samples, right?
Yeah.
19 of them, that would be true.
Yes.
Yes.
That's right. Yeah, because you've got all these proportions. We're just trying to be confident that the true value is somewhere there. Yeah, that's very good. Margin of error. Now, you've already done it. You found it from that table. Find the margin of error of P and then the number of Australians with brothers in the sample. So, margin of error we've got over here. That's, what's that? Margin of error is equal to 0.1, not 0.01, sorry. 19701. That's the margin of error. Okay, and the number. How do you work out the number? Same thing. So I am about 1.1% off in terms of my error. So times this by 5,000. So let's see how far off I am. 0.011970101965 times 5,000. Oh, whoops. I'm about 59.8 people off. So when we make this prediction, my error, 59.8. So it's take the mean plus or minus either direction. Yeah, so plus or minus, that's my margin of error. I'm about close to 60 people off. Plus or minus 60. Does that make sense? All right. All right, team. Can we now, was it 3 o'clock? Oh, I'm really pushing it. Margin of error. Yeah, we can do this one. Last one. Let's do the last page. All right, let's go. All right, this question, I've broken it down for you. This question is using the formula. Here we go. Eyes and ears towards the board. You are now trying to determine sample size. So how big should your sample size be if you want your error to only be 2%? You only be 2% error in an approximate 95% confidence interval. So there was an interval that you were 95% confident, but what if you want your error not to be any random error, but you want it to be 2% error? Okay, so plus or minus 2%. That's what you want. How big should your sample size be? So everything else is still the same. The sample proportion is estimated as 0.752. That's still the same thing. So 3760 out of 5,000 people. That's your proportion. Okay? Answer the question. Margin of error, you want 2%. That's 0.02. Confidence interval. I wanted, confidence level is 0.95, so 95% confident. Sample proportion, which we know is 0.752. Now you can use your formula to find out the sample size. Let's work it out. What is K in this case? 1.96. Very good. So it should be 1.96 over margin of error 0.02 squared times. Now this P star, I'll explain in the video, but essentially it is your sample proportion. Okay? So in this case here, 0.752 times 1 minus 0.752. Let's work it out, team. Here we go. Let's type in our calculator. What's it again? 1.96 divided by 0.02 all squared times by 0.752 times 1 minus 0.752. Sample size. All right, team, what does this mean? Wrap it up. What does this actually mean? What's the question asking? You need this big of a sample size. So your group, you need that number of times, on how many times you need this to happen. You need that size each sample. Okay, because before was you get one sample of 5,000. How many times do you have to do that? You need 1,791 of those 5,000 people. Reality is that's really hard. How do you get 1,791 times of 5,000 people? That's a lot of trials, but it makes sense because if you did that many trials, that's why your margin of error is so little. Does that make sense? Okay, so that 1,791 is how big one sample size is. We only used once. We only had one set of 5,000 people, 3,760 had a brother, and we're using that to predict what is the population proportion. That's a good question. So then you're under. Yeah, so I would say if you said at least, then I probably would round it up. Yeah, I'll probably round it up to 1792 to ensure that it's less than 2% error. They usually should tell you, like, as in rounded to, like, if it's going to be this thing. Yeah. All right, team, I think the last bit you can do, you don't need me there. That's just find the approximate confidence interval of P by hand. So you can do that by hand. But that's it. That's C and D. Last session. I'll make one more video to tie it in theoretically, but that was the how. All right, team, we finished. Unit 4 is done. Thank you. I'm going to stop the video there.